This tutorial is about running chi-square in SPSS. We are going to use the example from this slide. Suppose you want to find out if males are more likely to be superintendents than females. You went to a school administrator conference and randomly selected 10 females and 10 males and asked if they are superintendents. Here is our data set. Chi-square is used to find out if there is a relationship between two nominal or categorical variables. Gender is a categorical variable, and we have the codings with 0 meaning female, and 1 means male. Superintendent is also a categorical variable. 0 means not a superintendent, 1 means yes. We're going to copy and paste the data into SPSS. Here is the data in the program. We have coding for gender and for superintendent. If you go to a variable view, we can make some changes to our data. Since we don't have any decimals, we can reduce the decimals to 0. Once we've done that, go back to data view. You can see that these are all whole numbers. Then we go back to variable view. We're going to label our coding. You label your coding values here. So for gender, 0 means female, and 1 means male. For superintendent, 0 means not a superintendent. So I'm going to write non-suped. And 1 means that person is a superintendent. I'm going to write suped for short. Okay. And then go back to your data view. So now, since we have labeled our code, if you click on here, this is a value label, value labels icon. So you see that our codes will change to the labels. If you click this, once again, it's go back to the coding, the numbers. Now we are ready to run chi-square. To run chi-square, you go from analyze, then descriptive statistics, then go to crosstabs. I'm going to move this. So in the crosstabs, I'm going to put gender as a columns and superintendent in the rows. And so there's a couple, there's several buttons here. Click on statistics, and we're going to get chi-square. Because we have gender and superintendent, these are nominal variables. To find out a relationship, the size of a relationship between these two categorical variables, we're going to look at phi and Cremer's v. And here, mostly we are interested in phi because each of our categorical variables has 2 levels, zeros and ones. And then continue. Then go in the click on cells. In the cells window, the observed counts is already checked. So observed counts is a number for male superintendents, number for female superintendents. Besides that, we also want to find out what are the expected counts. Expected counts is based on the distribution, superintendent and gender distribution in our sample. So what will be expected if there's no relationship between gender and the superintendent. I'm also going to get the percent, 0%, and column percent and total percent. And in residuals, that's a different. I'm going to check on standardized residuals. Basically, that's a difference between observed counts and expected counts. Then click on continue, and then the other one, I don't think that matters. The default will be fine. We don't need this, just cancel. Now, so here I'm going to check display cluster bar charts. So it will give us bar charts for our data. Then click on OK. So the output will come up. I'm going to move this into the window. So first, just case processing summary that you can see how many missing data you have. Here we have 20 observations. And this is the Crosstab table. This table is a bit long because we asked for a bit more things here. Yeah. But you can see that across this column column variable is gender, and what is go on the side is superintendent variable. And so for gender, the female and the males, and the order here is because we coded the females as 0 and the males as 1s. And on the side, we have superintendent, non-superintendent, and superintendent. Since non-superintendent are coded as zeros, so they come before superintendent. And these are observed counts or observed frequency in our data. We have in our data set, we have 10 people, they are not superintendents. Among the 10 people who are not superintendents, we have 7 females and 3 males. So the percentage within superintendent, that is 70% of these non-superintendents are female, and 30% are male. And this is the percent within the column total. So that is in our data set we have 10 females. So among the 10 females, we have 7 superintendents. So the percentage is also 70% here. And here that is the total. So 7 female non-superintendent is account for 35% of the 20 people. The expected count is if the null is true. That is, if the null is true, that is there's no relationship between gender and superintendency. So what is the expected counts? So if there is no relationship, because we have 10 females and 10 males, and we have 10 superintendents and 10 non-superintendents. So the expected counts for each of the cells here will be 5. 5 female superintendent, 5 female non-superintendent, 5 male superintendent, and 5 male non-superintendent. The residuals is the difference between the observed counts and the expected counts. So 7 minus 5 equals 2, and here 3 minus 5 equals -2. So if the discrepancy between observed counts and expected counts are large, the residuals will be large. And the residuals is related to our chi-square value. Yeah, so how different our observed frequencies is from the expected frequency. So here is the chi-square value computed from our data. So chi-square is 3.2 with degree freedom of 1, since this is a 2 by 2 cross contingency table or Crosstab. And so the likelihood to find a difference is large if the null is true is 7.4%, which is larger than our criterion value, which is 5%. So we fail to reject null, yeah, and we conclude that we do not, or the data does not suggest there is a relationship between gender and being a superintendent or not. Then move on. Yeah, so we'll see here. There's for 2 by 2 tables. Yeah, we would like the minimum expected counts is 5. So you do not want that expected counts in a 2x2 table to be less than 5. So that's determined by the sample size. So you need to have an adequate sample size to run a chi-square. And this table shows the phi and Cremer's V statistics. And phi, here we're more interested in phi because we have a 2x2 table, or each of our categorical variables has only 2 levels. So the phi coefficient is 0.4. Interpretation is similar to a correlation coefficient. Yeah. And this relationship is not statistically significant. So if we find a statistical significance by running chi-square, then we use the phi statistic to tell us, to inform us how large the relationship is. So chi-square tells us whether there is a relationship, and phi will tell you how large the relationship is. And then, yeah, so this is the bar chart for our superintendent and gender data. And this is, you will be able to interpret the frequency chart here. So that's a tutorial for chi-square.